Hello everyone, and welcome to Jam Academy. In this example, we have a crate of mass 4 kilograms being pulled from rest. It's important you note this, from rest, with a force whose magnitude is given by F equal to 5t raised to the power 2, which means that the force changes with time. If the crate accelerates with a constant acceleration, it's important that you know that the acceleration is constant, of 3 meters per second squared, determine the instantaneous power delivered to the crate by the force at t equal to 5 seconds. Now we will assume that the surface is smooth, which means there is absolutely no friction. Remember, the crate is being pulled from rest, which exactly implies that the initial velocity is equal to which implies that the initial velocity is 0. The acceleration of the crate is constant. The acceleration of the crate is equal to 3 meters per second squared. And we know that the magnitude of the force applied to the crate is equal to 5t squared. Now we have been asked to calculate the instantaneous power delivered to the crate by the force at t equal to 5. This is quite an interesting problem. Now, first of all, the instantaneous power P is simply defined as F dot V, which is equal to the force parallel to the direction of motion, or the force tangent to the path of motion multiplied by the velocity v. That is our definition. But what do we know? We know that v is equal to v naught plus at. The initial velocity is 0. If the initial velocity is 0, this would mean that v is equal to a multiplied by t. Hence, we can therefore see that the instantaneous power P will be equal to F, which is just 5t squared, multiplied by V, which is just at. If we simplify this, this will be equal to 5at squared. But the acceleration of the crate is constant, given by 3 meters per square seconds. This would mean that the instantaneous power as a function of time will be equal to 15t squared. This is the instantaneous power as a function of time. But we want to calculate the value at a specific time, t equal to 5 seconds. So this would mean that P will be equal to 15 multiplied by 5 all squared. Now 5 all squared is 25. 25 multiplied by 15. That gives us 375. So 375 watts. 375 watts, which is our answer. Thank you everyone for this, for your attention. If you have any question regarding your understanding of this problem, please ask in the discussion forum below this video. Thank you and remain wonderfully blessed. Bye-bye.